Yes, am I audible?
Yes, sir.
Okay. And my screen is visible, hopefully.
Yes, sir.
So we were discussing in the previous class the Bayesian networks, and we'll be continuing from that. Uh, so in the previous class, we discussed regarding this nodes, what can make up the Bayesian network basically. It is a nodes that we need to select, and then there are arrows between these nodes which reflect the information flow, that is the cause and the consequence relationship between the various nodes. And then we saw the basic this Bayesian network structure. For the example, we considered regarding this the cancer example that we discussed in the text matter. If you remember, guys, there was a patient having the symptoms of cancer, and we saw the various factors which can contribute to it, like smoking and the pollution thing, and all the other various factors that were there. And we selected a few basically keywords or terms that were used to represent our basic this Bayesian network. Fine. And then we also saw that the choice uh, of the key elements in the model, that matters basically. We need to opt for such values or such keywords or such nodes which can basically capture the qualitative relationship between the variables that we basically saw. And the variables, the choice should be like that. Fine. Why it was like that? Because we saw we basically opted for the nodes which were basically Boolean in nature. So they were only capable to hold or capture the true or false values. But in reality, there can be, we saw the nodes can be of different types, the Boolean types, the integral ones, and the ordered values. Having the ordered nodes were which one? The which have the range of values. We saw that. For example, in the example we discussed the nature of the smoker. It can be low, medium, or high. So the range of values are there. And for similarly for the age groups, we saw uh, the age can be captured from the numbers between 1 to 100, and also we can basically capture the age according to the different groups, like young, uh, uh, old, and adolescent. So similar groups can be there now. So different capturing this approaches are there by which your this network should be built. But the ultimate thing is the choice should be such that the values they should be able to represent the domain efficiently. Fine. The it should be like this to choose the values that should represent the domain efficiently. So that was the basic conclusion that we discussed in the previous classes. Fine. So we were basically discussing this nodes and values. We were discussing the modeling choices are to be made and they are to be made effectively. Fine. For example, an alternative to represent the patient's exact age, it might be to clump the patient's age into the different age groups. We were basically capturing the this age of the patient from the number 1 to 100, simple in terms of numeric values. Or the alternate choice, it could have been in certain groups. The patient's age could have been captured in terms of this young, old, and other groups. Fine. The different ways are there, but the ultimate thing is the values should be such that they should be able to represent the domain effectively. That should be our objective while building the Bayesian networks. Fine. And then we were discussing the Bayesian network structure or the topology Fine. So what we saw in that basically was the different nodes were there that build up the Bayesian network, and we saw that if there was an effect or cause between the two nodes directly, then those two nodes should be connected directly. Fine. If one node affects or causes the other node, and if with the help of the arc indicating the direction of effect basically. So we basically, how we design the Bayesian network is, if two nodes are there, they should be connected directly if one affects or causes the other. Fine. With arc indicating the direction of effect. Fine. Now, for example, we discussed that lung cancer text basically, or the statements which were there with the doctor, and the doctor was basically trying to examine the effects that could have led to the cancer or something like that. So for assuming like if factors like this pollution or smoke, from these factors the cancer is basically resulting, then how we can capture this thing into our this Bayesian network. Fine. So the concept that we just discussed, it's like this thing. If the different nodes can be there, fine, and so this can be this arrow will be there, that is the direction marking the effects, and another this. Now suppose this is our factor pollution is there, and this factor is fine, and this is basically leading to cancer. So what we are discussing is, if the two nodes are causing the other one, then these nodes should be connected directly with the arc indicating the direction of effect basically. So what we're discussing is from that the text statement or the example that we were discussing in the previous class. If pollution and smoking are causing this cancer thing, then how you can represent is the pollution node is there, and this smoking node is there, and then this cancer node is there. Now this is basically getting resulted from these two nodes, pollution and smoking. So the arrow is from this parent nodes towards the this child node, that is the cancer node. Fine. And what further we can indicate is, uh, we also discussed another facts also, no? So that we will be trying to capture in our Bayesian network. So the other factors were the X-ray thing was there. If the X-ray is positive, and then we were also discussing one disease that was insomnia. Fine. Now these nodes are basically causing this, the cancer, the smoking and this pollution factors, and the cancer is there, then the X-ray report will be positive. X-ray report, it is going to be positive. Fine. It is going to be positive. And if the cancer is there with the patient, then there are also probability that the patient might be having this disease, that is dystonia, is it can be there with the patient itself. Fine. Now terminology that we are discussing here in this diagram is what is the terminology that we are discussing into this is node is there, nodes we are discussing, then the parent of the child, is there, that is if arc is there from the from former to later. Now former here is parent and the child here is the later part. Now in this diagram you can see that the parent child here in this is acting as this pollution node. Smoker node is also the parent node of this cancer node. Fine. And also these are the antecedent nodes also you can refer as smoker node and the this pollution nodes. They are also acting as the uh, this antecedent nodes. Fine. And similarly for these two nodes, that is this X-ray node and this dystonia node, the cancer node is acting as a parent node. Fine. And these are the child nodes of this the this cancer node. Fine. So we can also add up here in the terminology what is there, additional thing is there. We have the cancer node. It has got two parents. Fine. And X-ray is a child of cancer and descendant of smoker and pollution. Fine. So I hope this terminology should be clear. So this is also the part of this terminology. So this is the general terminology that we are basically discussing with respect to the our simple this Bayesian network diagram basically. Fine. Now we have with us the concept of conditional probability tables, that is CPTs, conditional probability tables. Now what is this is we will be discussing this. So after you specify the topology, find most you need to specify the conditional probability tables for each discrete node. Fine. Now here the nodes, these are the different nodes are here. This is one node, this is one node here, this is one node, this is cancer here is one node. So what we need to do is we need to represent the CPT values for the each node. यहाँ पे probability क्या हो सकती है, क्या आपके पास given factors हैं, यहाँ पे probability क्या हो सकती है, of cancer है या of any other disease, और यहाँ पे आपके पास क्या given है, यहाँ पे आपके पास क्या गिवन है और उसके बेसिस पे क्या प्रोबेबिलिटीज जो है आप कंप्यूट कर सकते हो. सो दैट इज व्हाट द सीपीटी इज. दैट इज विद रिस्पेक्ट टू द गिवन एविडेंस what probabilities can be possible here at here each and every node. So that is what you try to compute with the help of this conditional probability tables. Fine. And each row basically in this conditional probability table, it contains the conditional probability of each node value. Fine. Conditional probability of each node and the value for each possible combination of values in its parents nodes. So basically each row contains the conditional probability of each node value for each possible combination of values in its parents nodes. Fine. And this is basically why we are doing this, to quantify the relationship, between connected nodes. We'll be seeing these points, and also in this each row must sum to 1, that is the combined probabilities of all the cell values in the given row, it should be 1. And a node, what else is there when you try to build the conditional probability tables? A node with no parents has basically one row. Fine. That is basically the case of prior probabilities. तो इस केस में ये जो हमारा डायग्राम है, इस केस में ये जो नोड्स हैं इनके कोई पेरेंट्स नहीं है, स्मोकर और दिस पोल्यूशन, इट हैज गॉट, दीज नोड्स हैव गॉट नो पेरेंट्स. तो यहाँ पे सीपीटीज में एक ही रो होएगी, whereas for this cancer node it has got parent nodes also, so there the rows may be more than 1. Fine. And what else is there in this is in CPT is CPT for Boolean variable with n Boolean parents contains 2 raised to power n plus 1 probabilities. So this is the variable factor is there. If the number of variables are this, and if it has got n Boolean parents, then the number of probabilities it will be 2 raised to power n plus 1. So whatever the text I am writing in here is, that should be observed carefully. From this text also, you will be getting the questions in your this quiz and this MSTs. Fine. So next week we also be conducting this quiz for the part which we have discussed after MST1, and this text also should be observed carefully in whatever context we have discussed, the word files or the diagrams in the which we have used in our uh, discussions, in these kind of diagrams in the paintbrush and the text which we are using in this word files. So you might be getting this information from the links that I'm updating in your Google Classroom. So you need to observe the whole text carefully, and maybe on Monday. On Monday we'll be holding one quiz from the discussions that we have held after the MST1, and both in terms of this theoretical concepts and your this practical concepts. So continuing with this uh, about the conditional probability tables that we need to build for the each discrete node, it has got certain properties associated with itself. That is, each row must sum to 1. A node with no parents has one row. That is, when the parents are missing, then the row is going to be 1, and if the variable is having n Boolean parents, then the probabilities will be 2 raised to power n plus 1. Fine. So what we are discussing here is like uh, now this for the pollution. Now this is basically category of low, medium, and high. Fine. That we have described in our example statement. Fine. Now, if we try to build this conditional probability table for this, how you can build is uh, you need to draw like this, and here you can basically write probability this, and here you need to specify the value. Let us assume that it is 90%. So the probability with this uh, pollution node with L, M, and high, this is getting overwritten. Low, medium, and high. And with pollution as a low, in falling in the low category, the probability of the pollution having the value is 90%. Fine. That is, the one row is there. Now this pollution node is not having any parent node, so only this single value is there. That is, single row is there. The probability with pollution falling into the low category, here it is low is there. Here it is low category is there. Just a second. Different categories are there now for the pollution. So here it is low, medium, or high. The probability with pollution falling into the low category is estimated to have the value of 90%. Fine. Now similarly for this smoke care part, if I need to compute the CPT, that is, we are now computing the conditional probability tables. Conditional probability table. What is there in this is, if we need to compute the values in here, then how you will be computing here for the smoking thing is, again you need to draw the box here, then this, then you have probability as smoking equal to true. This is if smoking, this is a Boolean node. If this is a Boolean node, that is either it can have the value true or false. True or false. And here I am assuming that probability of the value of this node being the probability of smoking being true is the value, it might be 30%, leading to the cancer thing. Fine. So this is how the conditional probability tables basically look like. For here, for the pollution node, you try to compute this CPT. Single row will be there because it hasn't got any parent node over there. And similarly for this smoking node, you'll try to compute the value for the probability with smoking having value true, with value true is 30%. Fine. Now for this node, that is the cancer node, if we try to compute our CPT, now here we will be having different factors coming into the picture. One is probability P is there. Pollution, that is this cancer node is having the parent nodes also, na? One is the pollution node, that is P, and one will be this smoking node, that is with S. And here you will be computing the probability of cancer being true, given this is coming out of the box, given this pollution and smoking node values. Fine. तो ये हम ऐसे ही रीड करते थे ना एक्सप्रेशन को, जो प्रोबेबिलिटी नोटेशंस थी हमारी, कि what can be the probability values for this cancer being true with given these this pollution and this smoking node values, that is this one. Now ये जो pollution node है इसकी वैल्यू क्या हो सकती है, high, and we were discussing this low, medium, high thing, है ना? So for this high can be there, pollution can be high, and smoking is either true. Fine. Again, this pollution node can be high and smoking is false. Again, the pollution node, if it is low, pollution node is low and smoking is true. And again here, if the pollution is low and the smoking is false. ये मीडियम भी हम यहाँ पे कैप्चर कर सकते हैं, फॉर द पोल्यूशन नोड बॉक्स के बाहर आ जाएगा वो मीडियम, यहाँ पे मीडियम आ जाएगा, एंड यहाँ पे आपका अगेन ट्रू, अगेन यहाँ पे आपका मीडियम आ गया, और यहाँ पे आपका स्मोकिंग का क्या आएगा, फॉल्स. So you basically try to capture the all the scenarios प्रो ये जो पोल्यूशन नोड है ये क्या क्या वैल्यूज ले सकता है? आइदर इट कैन बी लो, मीडियम और हाई। अगर हाई है तो स्मोकिंग नोड की क्या वैल्यू हो सकती है? तो ये बुलियन नोड थी हमारी। आइदर इट कैन हैव ट्रू वैल्यू और द फॉल्स वैल्यू। And similarly for this, hello, yes, yes, जी जी बताएं। हम्म, हम्म, वो मैं करवा दूंगा। आई विल अपडेट दैट इन द कमिंग डेज। कब तक करवा सकते हैं अपडेट? आई ट्राई टू डू दैट एज सुन एज पॉसिबल। हाँ नहीं, अभी तो कोई वो है नहीं रिक्वायरमेंट। सो यहाँ पे हम आ गए हैं थर्ड इस पे, जो प्रोबेबिलिटीज हमने कंप्यूट करनी है। तो इट कैन बी सम डिफरेंट वैल्यूज कैन बी देयर, लाइक the first scenario it can be 0.05, then 0.02, something like that, 0.03, then 0.001, then again it can be 0.06, 0.04, so something like that. सो सीपीटी यहाँ पे आप देखें, अगर इसका जो कैंसर नोड का हम सीपीटी टेबल कंस्ट्रक्ट कर रहे हैं, तो इसमें इस केस में इस नोड के जो पेरेंट नोड्स भी हैं, so that's why you will be having more than one rows। ठीक है, यहाँ पे रो एक ही रो थी हमारी, यहाँ पे there are more than one rows because this node is having the parent nodes also। तो यहाँ जब अब यहाँ पे बेसिकली ये रिफ्लेक्ट हो रहा है कि जहाँ पे और भी नोड्स अफेक्ट कर रही है ना, तो उनकी भी जो वैल्यूज है वो भी कंसिडर करनी पड़ेंगी। देन यू कैन बेसिकली कंप्यूट द दिस probability values for this cancer node. Fine. So what you are trying to compute here is the probability value for the cancer node with cancer being true, and given is this pollution node values and this smoking node values. Then this is how you basically try to compute the CPT table for the cancer node. Fine. And similarly for this X-ray node, you can build your CPT table like this. What you can have here in this is cancer factor is that what you can have X equal to positive given the cancer value. Fine. So you try to compute here can be true, can be false, and for this you try to compute the values. So value it can be like this, or here it can be like this. Fine. So what you're trying to compute here in this is with X-ray report as a positive and given cancer, the probability of cancer having the true value is 90%, and the probability having the cancer as a false value, it can be 20%. Fine. So again here in this, as it has got its parent nodes also, so it is having this more than one row value. So similarly for this other nodes, you can build your this conditional probability tables. Fine. So what basically this is, for each node you need to look at all the possible combination of values of those parent nodes. Fine. And each such combination is basically called the instantiation of parent node. So you need to look at all the possible combinations of values of those parent nodes for building the CPT. At each node, you need to consider all the possible values of its parent nodes, and each such combination is basically called the instantiation of the parent node. Each this combination, the different rows are basically the combination of the different possible values of all the parent nodes. Fine. So each such combination is basically referred to as the instantiation of the parent set, basically. Instantiation of the parent set. Fine. And while building CPTs, for each node, the node has got many parents, or if the parents can have the large number of values, then the CPTs they can have then the CPT set basically it can be very large. It can be very large. तो अगर दो मतलब ये हम बात कर रहे हैं CPTs के regarding, if we try to build the CPTs for our given problem, and अगर उसमें the nodes have got many parents, fine, many parent nodes, or जो parent nodes हैं, if they are having the large number of values, then जो आपका CPT जो बनेगा that could be very large. Fine. So that is the other side of having this CPTs in our this Bayesian networks. Fine. So for covering up that, we basically use Markov models that basically come into the picture. We try to basically incorporate the Markov models in our for the given problems using this various set of probability theories. Fine. So we will see that what this Markov model is and how we can use that with respect to our given problem. Fine. So if we summarize up what the today's session we discussed, we basically saw that the Bayesian networks, they should basically capture the qualitative relationship between the variables that we are using. The effective choice has to be there while building the Bayesian networks. And if there is a cause and effect relationship between the different nodes given in the Bayesian network, then that should be reflected with the help of connecting the nodes directly and with the arrows indicating the cause or effects flowing from one direction to the another. The from direction, the node from which the effects are getting carried forward is basically called the parent nodes, and towards the node to which the facts are getting carried, those are basically the child nodes. Fine. And this we saw how you can build up the simple Bayesian network with given cause factors and the resulting factors. We saw that in this. The pollution and smoking factors were leading to the cancer node, and further the cancers will be affecting in the positive X-ray reports and the disease itself, that is dystonia. And what else we saw was, once you have this Bayesian network in place, how you can build the conditional probability tables basically. So you need to describe the conditional probability tables for each node. That is what we discussed here. Conditional probabilities for the each node, and the total probabilities for the each row, they must equal to 1. And the node with no parents, they will be having only one row. And the CPT for the Boolean variable with n Boolean parents, they will be containing 2 raised to power n plus 1 probabilities. Fine. For each node, we try to look at all the possible combinations of values of those parent nodes. Each such combination is basically called the instantiation of the parent set. तो जब भी आप parent node की values को आप consider कर रहे हो, each combination of the values of the parent nodes basically is called the instantiation of the parent set. Fine. And while building the CPTs, अगर parent nodes की जो values हैं वो ज़्यादा हैं या ज़्यादा parents हैं किसी node के, then जो resulting CPT आपका हो सकता है वो काफ़ी large हो सकता है. So to overcome this, you can say this feature, we basically bring the Markov models into the picture. Fine. So this we will continue with the next session along with the quiz and questioning on the topics after the MST1. So please go through the topics which have been uploaded on the Google Classrooms. Any PPTs or any video lectures, please go through them comprehensively, and this text also. And we'll be conducting this quiz. And fine. So please go through the contents thoroughly. And your this quiz thing will be having your performances getting added up into the final evaluations also. So if any doubts are there, you can let me know, and you can discuss, or if any, you can post also your queries in the chat message. Any queries are there, you can discuss it.